All right, so day 2, sum and product of roots. So now let's use the sum and product of roots to actually write polynomial functions. Find the equation of the quadratic function with integral coefficients if one of its roots is 3 minus 4i. Okay, so the first thing I need you to understand, as soon as you're given a complex root, you know 3 plus 4i is also a root. Okay, these always occur in pairs. All right, so we're looking for a quadratic function. So quadratics are in the form ax squared plus bx plus c. And we're going to use this often, okay? So if I have my quadratic, I'm going to factor an a out. And remember that factoring is dividing out, so that goes away. If I'm going to divide out, and it's leaving me with x squared, okay, if I'm going to divide that out, it's b over a times x. I know I'm missing this. I'll get there. And then when I divide it out of the constant term, then it leaves me with c over a. Okay. Now let's go to what we know about our sum and our product. So n is 2. It's an even function, so I know the product of the roots is c over a. I know the sum of the roots is negative b over a. Let me use all lowercase here. So look at here. Here's c over a. That's the product of my roots. Here's b over a, that's the sum of my roots, but in order to make this a plus sign, I have to subtract the opposite that I have there. So the sum is negative b over a. So if I take out a negative sign in front of here, I'm still left with my plus sign from the original. So look at how this works out for you. To write a quadratic function will always be in the form f of x equals a x squared minus the sum of the roots times x plus the product of the roots. And let me fix one thing here. This parenthesis actually shouldn't be here. It would just be a times x squared and then plus the product of the roots. Okay, so this is going to save you a lot of time, and we'll talk about the alternative. All right, so let me find those things. Sum of the roots, we have 3 minus 4i plus 3 plus 4i. So when I add those together, I just get 6 because the imaginary parts cancel out. The product of the roots, 3 minus 4i times 3 plus 4i. So if I go through my foiling, first, outer, inner, last. These complex roots, we saw this in Unit 1, the imaginary part cancels out. I squared is equal to negative 1. So I get 9 plus 16, which is 25. So now putting this back together, remember what the original was, right? Find an equation of the quadratic function. So both of these, if I think about dividing them, they would be divided by 1. So that tells me a is equal to 1. So my quadratic function is x squared minus the sum of the roots, so minus 6x plus the product of the roots, so plus 25. And there's my function. We'll talk about the alternative in class, but I promise you this is easier. Little note to myself so I don't forget to talk about it. All right, find the equation of the cubic function with integral coefficients if its roots are 2, 3, and negative 5. Okay, so if I have the roots, I can automatically go to the factors. Okay, so if x is equal to 2 is a root, x minus 2 is a factor. If x equals 3 is a root, x minus 3 is a factor. If x equals negative 5 is a root, x plus 5 is a factor. So then to find what the actual function would be, I can just simply multiply my 3 factors. Okay, so for homework, I want you to find f of x in standard form. Okay, so multiply those out, and I want it in the form where your exponents are going to descend in order. Again, the alternate solution, we'll talk about that in class as well. Okay, next one. Find the equation of a quadratic function with integral coefficients if its roots are given. Okay, so here we go again. Quadratic function. So f of x equals ax squared minus the sum of the roots times x plus the product of the roots. Okay, so our sum, negative 1/2 plus 3/5. Okay, so my common denominator would be 10. Multiply the first one by 2 over 2. Or excuse me, the second one by 2 over 2. The first one by 5 over 5. So I get negative 5 plus 6 divided by 10. So the sum of my roots is 1/10. The product of my roots then, negative 1/2 times 3/5. So negative 3 over 10. Okay, so remember what this looks like. The sum came from b over a, and the product came from c over a. So now that I have this rational value for my sum and my product, I see that my lead coefficient here is equal to 10. So putting all this together, f of x equals ax squared minus the sum plus the product. All right, so what happened to the 10 though? The 10 was my lead coefficient of a. So I'm not going to write this as negative 1/10 x. I need integral coefficients. So cleaning this up a little bit, I would expect you to write 10x squared minus x minus 3 as your quadratic function. And like the other two, there is an alternate solution. And we'll talk about that one as well. So we got a lot of work in class for these 4 examples. Okay, last example for the video. Find the equation of the cubic function, integral coefficients, if 2 roots are given. All right, so I have, if my root is negative 3 over 2, my factor would be 2x plus 3. If 1 minus square root of x is a root, then this is an irrational root. So 1 plus the square root of 6 has to be a root as well. Okay, and that was theorem, which number is that? So that's theorem 3. So your irrational and your complex roots always occur in pairs. Okay, so I know 2x plus 3 is a root. So I'm going to leave that as such. Now, using my irrational roots, I'm going to write a quadratic for these 2 pieces of information. So the sum of my roots Your irrational and your imaginary, your complex roots, they always cancel out the radical term when I add them together. So the sum of the roots is 2. The product of the roots, again, it has a lot of the same properties of your complex roots. First, outer, inner, last. My middle terms will always cancel. So the product of my roots is a -5. So from these two pieces of information, I can write a quadratic. X squared minus the sum of my roots times x plus the product of my roots. Okay, so I'm going to take this information, I'm going to take that quadratic, and I'm going to multiply the other rational root that was given to me. And we do want these in standard form. So now I'm going to FOIL this out. First, I'm going to distribute a 2x to everything. So 2x times x squared gives me my 2x cubed. 2x times -2x is -4x squared. 2x times -5, -10x. Distribute the 3 plus 3x squared minus 6x minus 15. All right, combining like terms, 2x cubed, -4 plus 3 gives me a -x squared, -10 minus 6, -16x minus 15. So here's my cubic function with those 3 roots. And like the other 3, we'll talk about an alternate solution, but I promise you it's not as fun. Okay, and that's it for the video. No additional homework other than multiply that out and determine that cubic function in standard form.